Intermediate Algebra Section 2.3. When we have linear equations graphed in a straight line, we describe the slant or steepness of the line by the term slope, which is known as a ratio of the horizontal and vertical differences. So when we have a slope of a line passing through these two generic points, we can define it as the following. Typically, we let the letter M stand for slope. It's a description, as I said, of the slant or steepness and essentially a change in the vertical and horizontal displacement of the lines. We can symbolize that with delta from the Greek alphabet, which means change. It's the change in the y's over the changes in the x's. And in terms of a formula, if we want to find that given 2 points, we can find the difference between the y values. We can take y sub 1 minus y sub 2, the y components of the 2 points, any 2 points on the line for that matter. And if we start with this y, we need to start with this x when we're looking for the change in the run, or specifically the change in the x values. So x1 minus x2. Which point we start with is meaningless, so you also might be seeing this version for slope where they start with y sub 2 minus y sub 1. And again, if we start with this y coordinate of this point, we need to be sure that we start with the x component of the same point. So let's take a look at finding a slope of a line when we're given 2 points. So to do that, just for clarification, I'll give these points subscripts. And to find the slope, we just defined it, and it doesn't matter which formula you use. y1 minus y2, essentially the change in the y values over the change in the x values. Whoops, I need to put a 1 and a 2. So I'm going to use my y1, which is 4, minus y2, which I assigned the value 8, over, starting with this y, we need to start with this x, 3 minus 5. Well, 4 minus 8 is negative 4. 3 minus 5 is negative 2. A negative divided by a negative is a positive. 4 divided by 2 is 2. So we have a slope of 2. Just to show the order doesn't make any difference, we could have just as well started here with the y, 8, minus this y. And since we started with this y, we need to start with this x for our change in our x values, minus the other x. 8 minus 4 is 4. 5 minus 3 is 2. 4 divided by 2 is 2. So the description of the line containing these 2 points has a slope or a steepness of a positive 2. And just a quick, rough representation of what this looks like. So if we're at 1, 2, 3, 1, 2, 3, 4, and we're at 1, 2 more, so we're at 5 out, and we're up here at 4, 5, 6, 7, 8. So if we had a line that was running, and this is, like I said, a very rough graph of the situation, but if we were talking about directions, we're sitting here at this point and we want to get to this point, we could tell someone direction-wise, you need to rise 4 and run 2. We're here at 3 and we're going to 5. And if we do that rise over run, 4 over 2, we end up with a simplification of a slope of 2. We could just as well have gone up 2 and over 1 and up another 2 and over 1 and still intersected the line. So this is just a shortcut. Graphing things to find slope is going to take time, and sometimes slopes aren't always nice integer answers, so it's nice to have the formula and use the power of algebra. In this next example, same thing again, they're asking us for slope, and if it helps to assign the values to the components, by all means do that. The formula then for the slope, if we use the same version that we did on the last one, we'll start with the subscript of 1 followed by 2. y1 we identified as 4 minus y2, which is 7. x1 is a negative 2 minus, and this minus subtraction here does not take the place of the negative on the x value. 4 minus 7, or 4 plus a negative 7, is a negative 3. Minus a minus is a plus, so we have negative 2 plus 4 leaves us with 2. So our slope is a negative 3/2.